although this stuff helps, not officially on it, but it does help, so we're going up to page 10 for tomorrow. Okay, we have done this already in our relations unit. Remember, in our relations unit, sometimes you would get an equation, and I would ask you to say, hey, we can show a relation as an equation, a graph, an arrow diagram, a table of values, ordered pairs. We had all of those ways that we could show something in our relations unit. So in this unit, what we really want to do is we want to go from the equation to the graph. But often you can't do it directly. You need to go to something in between. And method 1 for graphing a line, the thing that we're going to do to go in between is our table of values. Remember making our table of values with an X and a Y and a little chart? And then put in a couple of values for X, plug them into the equation, and you can find out what the values are for Y. Those points on your table of values are actually points on the graph. Then you can draw the graph. The 3 points should show up to be a straight line. If the 3 points show up to be a straight line, you can draw a straight line, add arrowheads on the end, and you are good. So, start off with y equals x. As far as our table of values go, we always put x first, our independent value, and y second, our dependent one. This is always your x-axis. This is always your y-axis. And this is a pretty straightforward equation. Pick a value for x. 1. Now, some absolutely terrifying calculations. You plug in 1 for the x and figure out what y is. 1. Oh, you guys are haunted. What would be another x value? You could pick 2. You plug in x2, do a bunch of heavy calculations mentally, and you would get 2. Wow. You guys are really impressive. Now, they don't always have to be positive values. You could put in negative values as well. Like, most people, when I do 1 and 2, what do you think they're going to say next? 3, right? It doesn't have to be in order. You could pick negative 3.
But it's still 3.
And negative 3 for x would become negative 3. Now, when we plot these points, can you see that 1, 1 would be right there? 2, 2 would be right there. We'll label that one. And negative 3, negative 3 would be down there. Do they form a nice straight line? Yes, they do. So we draw the line through the points that we have and put arrowheads on the end to say it goes on forever. And this is the graph of y equals x. That's a very famous, as far as lines go. That's a pretty famous one. Example 2. Y equals 2x. Now, a favorite one that is always good to put in a table of values is your y-intercept. You can always find where it crosses the y-axis because you know what the x value is going to be on there. Think about any point on this graph. What's the x coordinate going to be? If I labeled one at random, right? What's the x coordinate at that point? 0. What's the x coordinate of that point? 0. No matter where you put it on the y-axis, your x coordinate will be 0. So in our table of values, that is often one that is recommended to do. Also because it's usually easy mental math. It'll be 0. So we now know we have this point, 0, 0. What happens if you plug in 1? You would get 2. What number do we want to put in next? 2? Okay. What happens if you put in 2? You get 4. Do they look like they're making a straight line? So you draw with your ruler a straight line through them all, add arrowheads on the end, and we have our graph. Yes?
Doesn't it not work with negative numbers though?
Let's try. What negative number would you like to try?
Say negative 2.
-2. If you plug in -2 for x, what do you get? -4. And it does work as long as your line was drawn with a ruler. Oh, just a little bit off, but not bad. Graph a line of 1/2 x. Zero would be a good one to do again. Okay? Just plugging in 0. What's 1/2 times 0? 0. So I know I have this one. Why might I not want to choose 1? 1's not bad.
2.
2 would be better. Why would I like 2 better than 1 as my next
Actually,
x?
you gotta do a half of
Yeah.
one.
Yeah, because if I do 2, half of 2 is 1, it's a nice point on my graph. Whereas the other one's not that. It's not nice, but it's just you have to estimate where a half would be. It's not a perfect on your grid point. What would be another point that would be okay to put in for x? 4. And then you would get 2. Sure enough, those 3 are in a straight line. Put arrowheads on the end. And we have our graph. Is this an easy way to graph? Yes. This is actually the most powerful graphing method for anything. You can always make a table of values and draw any graph. However, it is not the fastest way to graph things. So that it's like there's a method that always works, and then there's a faster way, right? And so methods that always work are good to have, because if you're stuck, you've got something to fall back and say, I can always do a table of values and draw any graph. Right now, we're only graphing lines, so table of values works very good. But you could graph, like next semester, some of you are going to graph this shape. Does anyone know what that shape is called?
Y or X.
Now that would be, you're trying to find the equation, but it has a name. Like this shape is called a straight line. Next semester you graph that shape. The equation for that shape is this, or some version of it, y equals x squared. Because if you plug it in, if you plugged in 0, you would get 0. If you plugged in 1 squared, you get 1. If you plugged in 2, it would already go up to 4. If you plugged in -2 squared, it would still be positive 4. And you get this U-shaped graph. See if anyone's heard of the word before. I'll give you the first letter. Second letter.
A paw. Parable? Paraboles? Parable.
Parabola.
Parabola.
Oh. Do you have whiteout?
Do I white out?
Yeah.
I think I might. I might have just white out tape. Does that work?
Yeah.
Yes, it does. Okay. So the table of values always works, but then after we learn our table of values, then we start learning shortcut methods, which make things go faster, but sometimes you will forget shortcut methods. Can you see that we just did a table of values that all these points match up? If you did -1, you would get this one. If you did 3, you'd get 9. And you'd be like, oh, I have these points. It seems to be then I make this U-shaped graph, you now could graph a parabola, which is not supposed to be allowed yet because that's next semester in grade 11. But the table of values lets you do it, lets you figure it out, right? You could even do table of values for a bunch of things and find an x cubed graph and see what it looks like. And then I'd say, oh, you're not supposed to know the shape of that one until grade 12. But the table of values is so powerful. It lets you find everything, but it's slow. And when you get to crazy graphs, right, if you just did 3 points, how do we know it looks like that? Right? As the graph gets more complicated, you would need more points on your table of values to feel confident you know what the shape is. Because if you did the parabola and you just had these 3 points, how would you know the other side went up? So that's a limitation of table of values. But the table of values for a straight line is really nice, because technically you only need 2 points, and you would have a straight line. The reason that we do 3 is because if you go, here are my 3 points, I'm going to draw this straight line, you know that one of them is wrong, at least. Hopefully you didn't make all 3 wrong. But something mental math went bad if the 3 don't line up straight. So we do 3 as sort of just a verification that you're on the right track, that you haven't made a mistake along the way. So now, we're going to go back through examples 1 through 3, and we're going to find the slope. The slope is the rise over the run. You could take any 2 points you had on your graph, and remember, you could find the slope easily if you can draw it on a graph. What's the rise? What's the run? I went up 1, I went over 1, 1 over 1. The slope of this one is 1. Do I have to use the formula? No. You could, if you wanted to. You could choose this as your x1, y1, and this is your x2, y2, and you could use the formula. But if you've already got the picture, then it's really easy to draw the rise and run off your picture and just do it mental math. We already have the graph here. Let's say I choose this point and this point. You see the rise is 2, the run is 1. My slope would be 2. And in the third one, rise is 1, run is 2. And we get 1/2. Question says, if we did all of those slopes, what do we notice? The coefficient, which is the number in front of x, is the slope. Right? In this equation, 1/2x, slope is 1/2. And we kind of know this already because I've already showed you this in the last unit. Y equals mx plus b. The m is the slope. How come there's no b written in any of these first 3 examples? Because the y-intercept is 0. I mean, you could have said, graph the line of y equals 1/2 x plus 0. Okay? But that's not, it's not needed. Right? I guess you could do that with any question. You could solve 5x plus 3. And then, oh, I'm going to add a plus 0 on the side to make it look harder. Is our x? Is our y? Again, a really nice point to do is always to plug in 0 for x. What would your y value be? You plug in a 0 where the x is. It's going to be plus 1. So we go to our graph and we have the point 0, 1. Because that's on your y-axis, that's called your y-intercept. Tell me another value of x you could put in. 1. If you plug in 1, you're going to get negative 2. So I go to 1, and I get negative 2. Now, technically, you have 2 points. This would be enough to graph a straight line. But we do one more just to make sure we haven't done any mental math mistakes. So, what number do you want for next? 2. What do we get? Negative 5. Do those 3 points look like they line up perfectly in a straight line? Yes. So now we can draw the straight line. Put arrowheads on the end, and we have the graph. If you use the graph to calculate your slope, can you see that it's 1 this way and 3 down? The rise then is minus 3. The run is positive 1. Because you're going to get from this point to the next point, you're going over 1, down 3. Does that match up with y equals mx plus b? Yes, it does. What's our y-intercept? 1. We found it. Does it match up with y equals mx plus b? Yes.
Find the intercept.
Find the intercept. So plug in 0 for x. What would you get for y? 3. You get 0, 3. Tell me another point you could plug in.
1.
Plug in 1. Does it work out nice? If I plug in 1 for x, I'm going to get 6 plus 3y equals 9. What would y have to be?
1.
1. It does work out nice. Tell me another point.
2.
2. Does 2 work out nice? 6 times 2 would be 12. So what do you do if you can't do it all with mental math? You can do it off to the side. I can plug in 2. Do you see that that would look like this? And 6 times 2 is 12. So some people are really good at mental math. They can just see an answer. That's great. But if you struggle a little bit with mental math, you can use your equation solving skills. Can you see the 12 and the 9 are like terms? But they're on opposite side of the equation. So if I want to combine them, I'm going to subtract 12 on both sides so that they're on the same side. Then I would just get 3y equals 9 minus 12 is negative 3. And then the opposite of timesing by 3, I could divide both sides by 3, and then I would get y equals negative 1. So feel free to do some mental math calculations off the side, write down some of the steps just to make sure. You can always plug it in afterwards. What happens if I plug in 2 for x and negative 1 for y? And you see that you'll get 12 minus 3. Does that work out to 9? Yes, it does. And when I plug that point in to negative 1, do my 3 points match up in a straight line? Yes. Yes, they do. If I go from one point to the next, what is our slope? 1 to the right, 2 down. And you see that would be minus 2 over 1, which is just minus 2. Can you see that this line isn't in y equals mx plus b form? Right? You would have to rearrange it to make it. So this one, you can't see the slope from the equation right away. You can't see the y-intercept from the equation right away. However, now that we know our slope and we know our y-intercept, I'm going to tell you that this equation is the same as y equals negative 2x plus 3. Just written in a different way. So lines, you can write them in different ways and mean the same thing. Where have we seen that before? Fractions. Can you write two fractions that mean the same thing but look completely different?
Yes.
Yes. It's like 3/6 and 1/2. You're like, those are twins. Really? Totally different. But they're exact same. What's an easy value to plug in? 0 for x. Super helpful to find that y-intercept. If I plug in 0 for x, what would y be?
-1.
-1. Good. Mental math. What would be another nice value to plug in? 1? Let's try it. Plug in 1. You get 1 for y. Again, you could do that off to the side. Plug in 1. This will be -4. If I add 4 to both sides, combine my like terms, then I would get 2y is equal to 2. Divide both sides by 2, I'd get y equals 1. Sure enough, it works. So I have 0, -1. I have 1, 1. Another value, 2. You plug in 2, you get -8. And y would be 3. -8 plus 6 is -2. Check it out, 2, 3. They work out nicely on a straight line. Can you see that on this straight line you're going over 1, up 2, so our slope rise is 2, run is 1. Our slope is 2. You could rearrange this equation and have it look like y equals 2x minus 1.
Can I see number 5?
Yes, but before we go back to number 5, I have a question for you. Can you see that we went from the equation to the table of values, to the graph, to that equation? That's the method that we went. Can anyone see how they would go just from that equation to that equation? What math would you have to do if you just said, I don't want to draw the table of values, I don't want to draw the graph, I don't want to figure out the slope, and then write the equation again? Could I just go from one equation to the other? So I'm starting with this. And I want to get, in my head, I'm thinking, I want it to look like this. Well, if I want it to look like y equals mx plus b, can you see that the y is all by itself? Yes? And right now, the y has the 4x on the same side. What could I do with this minus 4x to move it to the other side? Well, what would happen if you added 4x to both sides? Can you see that that would get rid of the 4x on the left? And then I would have 2y equals, and I could write minus 2 plus 4x, but I could also write 4x minus 2. Do you see that I chose to write the 4x first because in y equals mx plus b, the x is before the b? Now, I want just a y. But right now that y is multiplied by 2. What should I do? Divide everything by 2. And if I divide this side by 2, I have to divide this whole side by 2. If I divide this side by 2, I get y. If I divide this whole side by 2, do you see that the 4 would get divided by 2? And the minus 2 would get divided by 2. And we went from this equation with the purple arrow directly to that equation right away. And can you see if you went to that equation, you could go right away, wow, the arrow's a little bent, to that y-intercept right away. And you could go right away to that slope. And if you had that slope, went over 1 up 2, you'd find this point, and you went over 1 up 2, and you could find this point, and then this point, and then this point, and find points that way. That's a bit of a shortcut method, right? The y equals mx plus b. Look how many points we were able to do very quickly with the slope. Over 1 up 2, over 1 up 2, over 1 up 2. Much quicker than the table of values. So, again, we're going to get towards that shortcut, but the table of values is super powerful right now. And it's neat to see that you can go in one direction to find something, but you're like, oh, I can also work in a different direction to find the same thing. Haley, you wanted to see question number 5? Okay, this was our last example, so you have your worksheet listed at the bottom. We can use the rest of time in class to work on that. And here is example 5.